Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to understand the various types of triangles by their angle and side measures, how to recognize congruence in geometric figures, how to use the SSS theorem and SAS theorem to prove that two triangles are congruent, how to use the ASA theorem and AAS postulate to prove that two triangles are congruent, how to recognize that if two triangles are congruent, all of their corresponding parts are also congruent, how to recognize congruent geometric figures as being transformations, how to write a formal proof to show that two triangles are congruent, how to find the side length of a triangle, and how to prove that inscribed polygons are congruent. How are we learning it? Through the Triangle Congruences and Geometric Proofs Review Notes and the Triangle Congruences and Geometric Proofs Review Assignment. When can we use this information? To recognize similarities and differences that will allow you to distinguish between solutions in your life, to group items together based on limited but similar information, to formulate well-thought, articulated arguments to defend your opinions on various topics, and to determine the size and amount of planks needed to construct a triangular planter. How do you know you learned it? By getting a score of 4 on the Triangle Congruences and Geometric Proofs Review Assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Triangle Congruences and Geometric Proofs Review Notes, and then I'll give you time to complete the Triangle Congruences and Geometric Proofs Review Assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the Triangle Congruences and Geometric Proofs Notes. The notes begin with the learning goals and success criteria. Now, understanding congruence. In order to show that two triangles are congruent, we must show that all the sides and all the angles are congruent. So first we need to state the parts that are congruent. Well, we have AB here with a single dash, and we have DE here with a single dash, so those are congruent. Now notice, I said AB is congruent to DE. I didn't say AB is congruent to ED, because that is not a true statement. In order to make a true statement, I need to follow along with the corresponding parts. So I went from the endpoint with the double arc to the endpoint with the 90-degree angle. So I need to do the same thing here. Endpoint with the double arc to the endpoint with the 90-degree angle. So it's AB is congruent to DE. Then we have BC here is congruent to EF, and AC is congruent to DF. So those show that all the parts are congruent. Then I have my angles. Angle ABC is congruent to angle DEF because they're both 90 degrees. They both have the box. Then I have angle ACB, so the single arc, is congruent to DFE, single arc as well. And then I'll do my double arc. So BAC is congruent to EDF, and those are congruent. So now we've shown that all the sides and all the angles are congruent, so therefore the triangles are congruent. So we can now say that triangle ABC is congruent to triangle DEF. Now let's take a look at side-side-side congruence. And what side-side-side congruence says is that if we know that all the sides are congruent, then the triangles must also be congruent. So again, we can say that AB is congruent to DE. We could say that BC is congruent to EF, and AC is congruent to DF. Therefore, we know that the triangles must be congruent because all of the sides are congruent. So because of side, 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 we know that triangle ABC is congruent to triangle DEF. Now let's take a look at side angle side congruence. So side angle side congruence says that if we know that two sides and the angle between them are congruent, then the triangles are congruent. Now notice here, I have a side, an angle, and a side. The order matters. If I had a side, and I knew this angle, then this theorem would not work. The only way it works is if we have the two sides and the angle that goes between them. So here we know that AB is congruent to DE. And between them, we know that there's an angle here, angle ABC, that's congruent to angle DEF. And then we know that side BC is congruent to side EF. Therefore, we have two sides and an angle between them that are congruent, so therefore we can say that triangle ABC is congruent to triangle DEF. Now let's take a look at angle-side-angle congruence. The angle-side-angle congruence says that if we know two angles and the side between the two angles are congruent, then the triangles are congruent. So if you notice, we have an angle, a side, and an angle. Again, order matters. So we have the side that we know comes between the two angles that we know. So then let's restate what we know. Well, we know side AB is congruent to side DE. We know angle ABC is congruent to angle DEF. And we know angle BAC is congruent to angle EDF. So therefore, we have two angles and a side between them that are congruent, so we can use the ASA theorem to state that the triangles are congruent. So we can say triangle ABC is congruent to triangle DEF. Now let's take a look at angle-angle-side congruence. So this says that if we know two angles and then the side after those two angles, then we know that the triangles are congruent. So here we have angle ABC is congruent to angle DEF. We have angle BAC is congruent to angle EDF. And we have side AC is congruent to side DF. So we have two angles and the side that comes after them are all congruent. So therefore, we would say the triangles are congruent. Triangle ABC is congruent to triangle DEF using angle-angle-side. Now let's take a look at the reflexive property. The reflexive property states that two lines can be determined to be congruent if they are identical, meaning they are a shared line between two polygons. So if we look at this, we have a triangle here and a triangle here that forms this rectangle. Well, this side here is in common. It's in both triangles, so it's the exact same side. So we can't say that AC is congruent to some other side. It's AC is congruent to side AC. So they're exactly the same. We call this the reflexive property because it is shared between the two triangles. So AC is congruent to AC. Now, what is a geometric proof? A geometric proof is a step-by-step explanation that uses definitions, properties, postulates, and previously learned theorems to draw a conclusion about a geometric statement. A geometric proof is typically done in a two-column proof with one column being the statements and the other being the reasons. So what do geometric proofs look like? They look like this. So we have a column here that represents our statements. This is what do we know? So these are the statements of we know this, we know that, and so on. Now the right side is the reasons, and that is the arguments for how we know that to be true. This is an example of a geometric proof. So it says AB is congruent to DE, and we have our reason as given. Given information is the information that they told us. So whether it's a marking or they state it in words, whatever it is, the given information is stuff that we didn't have to figure out on our own. It was told to us. Then we have AC is congruent to DE, given. Angle BAC is congruent to angle EDF, given. And then the triangles are congruent. Notice all of this was given information, but this part we had to come up with on our own, the SAS theorem, to prove that those triangles are congruent. So we use the theorems and postulates to fill in the rest of it. Other types of triangles, we have right triangles, where one of the angles is a right angle or a 90-degree angle. Acute triangles have all angles smaller than 90 degrees, and an obtuse triangle has one of the angles bigger than 90. So what does this look like? Right triangle has a 90-degree angle right here. Acute triangle, all the angles are smaller than 90. So in this case, they're all 60, but they don't have to all be the same. They just need to all be smaller than 90. And then obtuse has this big angle here that's bigger than 90, right? Because if I were to draw a right angle, it would go up like this. And it's definitely bigger than that. So that's an obtuse triangle. Now, what is a right triangle? A right triangle has a 90-degree angle. So it forms this perfect L shape here. And the sides are labeled A, B, and C. A and B are the two smaller sides. It doesn't matter which one's which. And the longest side is C, and that is the hypotenuse. So A, B, and C. This could be A, this could be B as well, but this one is always C. So what is the Pythagorean theorem? The Pythagorean theorem states that A squared plus B squared is equal to C squared. So the square of this side length and the square of this side length is equal to the square of this one. If we simplify it and just try to find c, that means c is equal to the square root of a squared plus b squared. So how do we find a side length? So let's say that this is 3 and this is 4, and we want to know what c is. So we're going to find the missing side length. So we have a squared plus b squared is equal to c squared. And so we plug in a is 3, b is 4, so we have 3 squared plus 4 squared is equal to c squared. So 3 squared is 9, 4 squared is 16. When we add those together, we get 25. So 25 is equal to c squared. Now, what is the square root of 25? Well, the square root of 25 is 5. So c is equal to 5. Let's look at another example. We have 4 and 5, and we need to find the hypotenuse. So we have a squared plus b squared is equal to c squared. We plug in 4 for a and 5 for b. So we get 4 squared plus 5 squared is equal to c squared. Well, 4 squared is 16, and 5 squared is 25. Then we add these together. So 16 plus 25 is 41. So we take the square root of that. And notice now there is no perfect square root of 41, so we'll just leave it like that. So c is the square root of 41. Or we can simplify it and say that c is equal to 6.40 by rounding. Let's look at another example. This time we know the hypotenuse, but we don't know one of the legs. We call these the legs. So again, we're going to say a squared plus b squared is equal to c squared. And we'll make a 2. And we don't know b, but we do know that 5 is c. So this is a squared plus 2 squared is equal to 5 squared. Well, 2 squared is 4. And 5 squared is 25. So we go ahead and subtract 4 from both sides, and we get a squared is equal to 21. We take the square root of 21, which doesn't go in evenly, so we'll go ahead and round it, so it becomes 4.58. Now there's a video here that shows you how you can check the Pythagorean theorem using Symbolab. So go ahead and watch that video now. Let's take a look now at how we can use Symbolab to check our work when dealing with the Pythagorean theorem. So we go to Symbolab, and we're going to go to where it says right-angled triangle, sides and angles calculator. So the first thing we need to figure out is which side are we trying to find? Are we trying to find A or B, or are we trying to find the length of C? So let's say we're trying to find the length of A. So we go here, and all it does is it asks you to put in B and C. So let's say B is 4 and C is 5. We go ahead and click Go. It shows us step by step how to do this, and it tells us that at the end, our A should be 3. So that other side length should be 3. Now let's say that we needed to find C. So we click there. Now it asks us to type in A and B. So let's say A is 3, B is 4. We go ahead and type that in and click Go. It shows us step by step how to do this and tells us that C is 5. So this is how you can use Symbolab to check your work when dealing with the Pythagorean theorem. Now let's take a look at how we can use the Pythagorean theorem to prove two triangles congruent. So if we look here, we have A, B, and C, and D, E, F here. And we notice that this is given and this is given. So these two side lengths are exactly the same. So BC is congruent to EF. So we know that's true, and that's given. And then we're told that this side is 5 and this side is 4. So if we can prove that these two triangles are congruent by their side lengths, then we can prove that the triangles are in fact congruent altogether. So if we take 3 squared plus b squared is equal to 5 squared, so we're going to find this side length here. Well, 3 squared is 9, and 5 squared is 25. We'll subtract 9 from both sides, so we get b squared is equal to 16. So we take the square root of 16, and we get 4. So we know that this side and this side are congruent as well. So AB is equal to 4. We need to state that because it's not given to us. So we know that AB is equal to 4, and we know that by the Pythagorean theorem. Now, if we can just get this side length, then we could say that the triangles are congruent. So we have 3 squared plus 4 squared is equal to c squared because we take these two side lengths. 3 squared is 9, And 4 squared is 16, so we get 9 plus 16 is equal to c squared. 9 plus 16 is 25. We take the square root of 25 and we get 5. So this side length, df, is equal to 5. And we know that by the Pythagorean theorem as well. So now we can state that AB is congruent to DE. And we know that because of the definition of congruent side lengths. So we're saying that if they have the same side lengths, then they must be congruent. And then same thing here. AC is congruent to DF for the same reason, definition of congruent side lengths. So now we have 1, 2, 3 sides congruent, so we can say that the triangles are congruent. Triangle ABC is congruent to triangle DEF, and we know that by the side theorem. Let's look at this example again. There's a shorter way we can do this as well. So same thing, we state what we know. We know BC and EF are congruent to each other, and we know that because it's given. Now, we also have this angle here that we know. So we know that angle ABC is congruent to angle DEF. That's given as well. So now if we can prove that this side and this side are congruent, then we can use side angle side to prove that the triangles are congruent. So now we take this, and we have 3 squared plus b squared is equal to 5 squared. Well, 3 squared is 9, and 5 squared is 25. Then we subtract 9 from both sides to get b squared by itself. And we get 25 minus 9 is 16. Take the square root of that, and we get b is equal to 4. So we're going to say that AB is equal to 4. Well, if this is 4 and this is 4, then they are congruent. So we can say that AB is congruent to DE, and that's by the definition of congruent side lengths. Now we can say that the triangles are congruent. Triangle ABC is congruent to triangle DEF by side angle side theorem. So proving congruent triangles within a polygon. So let's prove that these triangles are congruent. Well, we could see now that we have AB is congruent to CD here, these two sides. And we know that because it's given, right? They're both length 5. We could also say that BC is congruent to DA, and that's given as well because they're both 3. Now, this side here is shared. So using the reflexive property, we can say that these are congruent to each other as well. So this is AC is congruent to AC, and that is by the reflexive property. Now we can say that the triangles are congruent. Triangle ABC is congruent to triangle CDA, and we know that because of the side theorem, because we've proven all 3 sides are congruent. Let's look at another example. Now we have triangles within a circle. So we know that this is a radius. So all radii are exactly the same length. So this side, this side, this side, and this side are all the same. So we could say that AE is congruent to BE. And we know that because the definition of a radius. So it's not actually given. They didn't put any markings. But we know because it's a radius, it's the same. Then we could say that DE is congruent to CE. And that's also definition of a radius. So we know that these side lengths are congruent. We don't know anything about these two here. But we do notice this angle here forms this X shape. So now we can use vertical angles to prove that these two angles are the same. So we could say that angle AED is congruent to angle BEC, and that is by vertical angles. So now we have side, angle, side that we can use to prove that these two triangles are congruent. Let's take a look now at the triangle congruences and geometric proofs review assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says, what is the measure of the missing angle? Well, we can see that this is 86 and this is 41. And we know that the total of all the angles needs to end up being 180. So if we add 86 plus 41, we get 127. And if we subtract 180 minus 127, we get 53. So that would be our answer there. So we'll go ahead and mark that one. Then we'll move to the next one. It says, which side in the triangle below is congruent to AB? Well, we can see that AB is right here. And it's got one dash through it. This one has one dash in it. So it's got to be this side here. We just need to make sure that our parts match up. So if we said AB, that means we went from the double arc to the single arc. So we need to do the same thing here, from the double arc to the single arc. So it would be congruent to DE. So we'll go ahead and mark that one. And then we'll continue to answer each of these questions until we get to the end of the assignment. Once you get to the end of the assignment, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.